Thank you. Thank you very much. Okay, wow, it's all set up. This is lovely. Thank you very much. I really didn't understand just how much it means, that phrase, that's a tough act to follow. So I'll do my best. And my comment about being able to tell time in the stars, you'll see that at the end. That's always been an issue for people. And about 400 years ago, there started to be some rather interesting approaches taken to it. Okay, there. Okay, this is my pointer, actually. So I will bore some of you to tears again because I'm going to repeat. There's a nova coming on a star.
Always say that. They always say that.
Yeah. Well, I'll say it again. And because I don't like doing the same thing over and over, I just used the same slide. We're going to be able to see Saturn and Mercury in the west, phases of Venus and Mercury in the west, and there's a total eclipse in a month, lunar eclipse, which will be actually the night of the meeting. Yeah, so technically, I've gone a little bit off the rails. There's another lunar eclipse, just not of our moon, on March 22nd, and that's the last thing I'm going to talk about. I will say that with all the planets visible in the sky, literally every single one of them, this last 2 months, we've had uncommonly clear skies at times. And yes, it's actually been freezingly cold at -2 on occasion. For those of us who've worked and lived up north, it's just like spring. So yeah, trying to run a telescope in Dawson City in January is not fun. But it's been absolutely lovely being able to see all those beautiful planets up there. And wow. So away we go. Saturn and Mercury. This is what you will be able. No, wait a minute. Yes, T Corona Borealis. Does everybody know how to find Vega in the summer sky? It's part of the summer triangle. Yep. It's typically straight overhead in the summertime, and Lyra is that squashed. It's a parallelogram. Arcturus is, if you follow the arc of the Big Dipper, there's the bright star Arcturus. Between them, from Arcturus over here, there's the little semicircle Corona Borealis. This is the bright star, Alphecca. Here's Hercules with M13, that cluster right in about there. So it's 1/3, 2/3, 3/3. And this is where that star is going to be. It's magnitude 10. If you're on the internet, hit a site called, not Heavens Above, spaceweather.com, right, Charles? Yeah, spaceweather.com, top right. It's got a bunch of cool stuff on what the sun's doing, auroras and all this, but they're putting in a little day by day. Here's how bright this star is. It's going to go bang sooner or later and go from magnitude 10 all the way up to magnitude 2. So it'll be about as bright as that bright star in Corona Borealis. You're going to be able to see a planet-sized hydrogen bomb go off. And yes, I'm really happy it's 2,500 light years away. So now you can tell from this is a stellarium screenshot. I did this in June of last year because I was really excited about seeing it. Still waiting. Okay. Saturn and Mercury on the 24th, they'll be right beside each other, very low in the sky, like 4 degrees above the horizon. So go to Davis Bay, and because that's where you get the view. In case you want, Mercury will be quite bright. Saturn will not be, not nearly as bright as it normally is, because it's got rings. Much of the light you see when you look at Saturn is reflected off the rings. And as it comes around the sun, we're going through it, that plane goes across. And I believe it's in March when it actually, that plane hits Earth. And we're looking at it edge on, and we cannot see the rings anymore. So for 15 years after March, we'll be able to see the south ring, the south side of the rings and the south pole, Saturn. So it gets fainter and fainter until you start seeing more and more of the rings. And that's why the brightness of Saturn changes. So there's February 24th, Saturn and Mercury right beside each other. And you will be able to see Mercury if you've got a view at all. It's there, definitely. Phases of Venus. Now, if you haven't seen Venus in the western sky, you haven't looked, because it's there. It looks like an airplane landing light, okay? And it's done this big arc like that. One of the reasons is, the big reason that it does this sort of thing is we're moving too, and it's catching up with us. Its orbital plane is tipped relative to ours, and it's doing this. Now that's where the North Star is, so tip everything, and it climbs higher and higher in the sky. It's going to pass between us and the sun. It'll be 8.5 degrees higher than a line between the two of us. So we will see it not pass in front of the sun, but pass over it. And this is what it looks like tonight, an hour and a half ago. Well, no, 35 minutes ago. That's a stellarium screenshot. And you can see it's a crescent, but it's getting bigger all the time, thinner, but bigger as it comes closer and closer to us. And you can see it, the sun is obviously down to about the 4:30 position. That's what it'll look like in 10 days. It's slightly bigger, but now it's pointing at the 5 o'clock position. And March 6th, oh, that arc is pointing almost straight down. And there she be on the 16th, which is another 10 days. There's still a very faint crescent on the bottom of it. Some of it, I mean, it's being lit up, and that nice thick atmosphere pulls a little bit of light through it. And that's what you'll see. And you can see it as an evening star after sunset rather. And you'll see it the next day as a morning star before sunrise. And that'll continue for about a week. And then it's a morning star eventually, because as we turn, it sets after the sun and then comes up before it in the morning. So you can see it both ways. That little table there shows how far away we are from it. Right now it's 39 million miles away, and it's 39 arc seconds across. And 30 days from now, it'll be 2/3 as far from us, and we'll have gone from about 40 up to about 60 arc seconds, or 1/30th the diameter of the moon. You can see it beautifully in a good pair of binoculars. You can see the phases of Venus in binocs. And it's pretty awesome to be able to do that, especially if you got the moon right beside it, because it'll be a crescent moon. Do that in binoculars, you're hooked for life. I'm not joking. Okay, March 10th, Venus and Mercury. Venus is coming back down again because it's getting closer. It's March. And Mercury's up there, and they'll be 5 degrees apart and about 10 degrees above the horizon. Again, this is another Davis Bay moment. Now, 1 month from now, well, yeah, 1 month less a day. There's the moon. Now, our meeting will shut down about 9 o'clock. So you'll have about an hour to get home and look to the east. And that's what the moon will look like at about 10:10 p.m. on March 13th. And then, remember, the moon moves this way through the sky, but that way relative to the stars. Okay? It's going west to east around the Earth. It climbs in the sky out of the east, but the stars move faster. It's moving that way relative to the stars, and you can see the Earth's shadow there. It approached it from above and right and moved down into the shadow. And it just keeps doing that. So that's 2250. And by 1126, stellarium does some really interesting effects. As soon as it shows it's fully eclipsed, it shows the moon dimmer and brings up the stars, because realistically, you won't be looking at a full moon in the sky. It will be eclipsed and you'll be able to see those stars instead of just sort of squinting. So there you are at 1126, and by 1230, so the 14th, you can see it's starting to get a little bit light. And it's now moving out of the Earth's shadow. So it's caught the top half like that. And it comes out at about the 9 o'clock position, which is why that's lit up. You notice all the faint stuff behind it. It's not there anymore because you can't see it because it's too bright. And 1:30 and 1:47 is all she wrote. So this is a total lunar eclipse. If it's dark, you can see it, unless there's a mountain in the way or you live here. And my saying is, it's just we're 30,000 feet too short because we have 5 miles of cloud above us. But that's what it's going to look like. Excuse me. Now, the last thing, I've mentioned it in some of the articles I've written and 1 or 2 talks. Why are all the oldest established observatories run by navies? Navies. Greenwich was the Royal Navy. The one in France, whose name I forget, was the French Navy. There's the US Naval Observatory in Annapolis, all of them. Because if you're someplace on planet Earth in a boat that has sails, you can't go any place you want. So you're kind of limited in your mobility. If you look at a lot of the maps from antiquity, you know, where here be dragons or all this stuff, everything's squished and out of proportion because they had no way to tell really. You could figure out your latitude if you're north of the equator because you got the pole star. Its altitude is your latitude. Simple. And you're within half a degree, which is 30 nautical miles. So, I mean, that's like next door. Longitude, not so much. East-west is a problem. What you really need to know is how much east or west are we of some place that we know what is going to happen in the sky. And when Galileo put a telescope together and pointed it at Jupiter, he wrote there were up to four stars obviously going around Jupiter. This got him in a lot of trouble. But he was careful. He didn't get barbecued or anything like that. Some people did, or egregiously objecting. Anyway, it occurred to him, but he didn't have really the ability to do it accurately because nobody had invented actual clocks until roughly 1700, I think, an honest to God pendulum clock. When you do that, now you know what time it is, like to the minute or two, and you can reset it according to the sun every day. But that's only where you are, and a pendulum clock doesn't work on a boat. And it didn't take long until people were saying, well, you know, these moons go around Jupiter and we can predict what they're doing. And you can. As an example, this is March 22nd. Yeah, I know I'm going past, but beautiful little segue. And thank you, sir, for the what time is it intro. It's a blue background. With a good telescope, you can see Jupiter in the daytime. You can see its moons. And there they are, Io, Europa, Ganymede, and Callisto. Well, here it is at 1:22 p.m. 1 minute later, now I apologize for this thing moving around. I haven't figured out a way to absolutely register them and squish them down to get them onto these things. And those little four marks around Jupiter, those are just the reference indicators on the screen. You might notice Ganymede ain't quite so bright as it was a minute ago. And now it's 1:24, and oh, look, Ganymede it's small. It's the only way they can do the brightness. And there it is at 1:25, and it's basically a pinpoint. What happens is it's gone behind Jupiter into Jupiter's shadow. And you can time it to the minute. And when you see it happen, you know, okay, if the Greenwich Observatory publishes a book saying these events will happen at precisely this time, Greenwich, on this date, boom, this happens. Guess what? If you're on the other side of the planet and you can see Jupiter, you now know when you see that it's exactly such and such a time in Greenwich. If it was, say, 1:30, 1:25 in the afternoon, Greenwich time, let's assume this was Greenwich, and it's 8:25 in the morning, your time, you're 5 hours west, exactly. of Greenwich. Now you know your longitude. Galileo and others figured out Jupiter is simply a clock with 4 hands. Only you don't look at it this way, you look at it that way, on the edge. And you can see the events as the moons go around, and there's a clock in the sky. And all you need is a telescope and the book. Nowadays, you got GPS satellites, but it's the 17th century solution to where am I? Well, you have to know your time exactly. And this can give it to you to the minute. Local time. So that's it. Thank you very much.